Hello, my name is Christian Kahn, undergraduate of electrical engineering at the University of Central Florida. This video is for the hardware security and trusted circuit design class, and it will cover projects 1 and 4 in the class of having Trojan designs for both the Alpha program and the 8051 microprocessor. Both of these will be implemented on a Spartan 3E FPGA board, and enjoy. For project number 1, the Alpha program, I started my Trojan design process by modifying the hex values in the keyboard to ASCII file. In this program, all of the uppercase vowels, capital A, capital E, capital I, capital O, and capital U, all end up being lowercase. I shifted up the hex values 20 value places in the file. This was the first step made in a more advanced Trojan design, but it was a good way to understand how the keyboard to ASCII file worked, and this has no trigger, so it's not a triggered Trojan, it just occurs as we go. So here it is. So I'm going to start typing all uppercase values. I'm holding down the shift key. We have B, C, D. Now if I start using vowels, A ends up being lowercase, E ends up being lowercase. Let's do some more consonants. R, T, Q. We can do I, O, and U. So as you can see, the uppercase values are, the uppercase letters are only consonants because the vowel hexadecimal values in the file were shifted up by 20. For the second Trojan, I added the idea of a trigger. In other words, the Alpha program runs normally until a trigger is hit. For this implementation, the number 0 is the trigger. The Trojan then shifts the entire ASCII table up to the random characters in the ASCII table, which means that your output will be all gibberish. So to start off with, we have A, B, C lowercase, A, B, C uppercase, hit the number 0, and now we have random characters. This is A, B, C lowercase, A, B, C uppercase, and a few extra characters. For the third and final Trojan of the Alpha program, I decided to build off of the last 2 Trojans that have been shown and add another level of depth to it. So it does have the same trigger that the second Trojan has, which is the number 0. And when 0 is hit, the Trojan is triggered, and when that occurs, the ASCII table gets shifted up 1 hexadecimal value. So A becomes B, becomes C, C becomes D, etc. Now, I put this into a loop that has a loop counter inside of the keyboard to ASCII file. So every time I hit 0, it will continue to count up the ASCII table. So I'm going to say the names of the letters I'm pressing, and you'll see what happens. Lowercase a, lowercase b. Uppercase a, uppercase b. 0. Lowercase a, lowercase b. Uppercase a, uppercase b. 0. Lowercase a, lowercase b. Uppercase a, uppercase b. So as you can see here, I hit lowercase a, lowercase b. The first 4 are is the program working correctly, so they are their actual values. Every time I hit 0, it shifts the entire ASCII table up 1. So essentially, you have to keep hitting 0 until it runs all the way through the ASCII table, and it has to reset before it will go back. Now, if I try to reset this and come back to it, and I try to hit lowercase a again, it leaves off where we were. So the only way for me, I have to reprogram the entire thing. It freezes the program in where it is. So you can't just reset the program. You have to actually reprogram the FPGA to make it happen back to normal. So there we go.